Speed of sound in different media. Speed of sound varies from media to media. You know that sound travels in all types of media: solid, gas, and liquid. The material media. Sound waves are called mechanical waves. But the speed of sound, which is the rate at which the sound travels from the sound producing source to the ear, varies from media to media. What does it mean? So let us first define speed of sound. Speed of sound is the rate at which sound travels from the sound producing source to our ear. Now it depends on the material, the media through which it is traveling. Let's see how it happens. Let us take, for example, the media to be air. If it is air, the speed of sound is 344 meter per second at room temperature. So we are seeing this at room temperature. Very important to say that, because we will realize later that the speed of sound depends on temperature also. So at room temperature, if the medium is air, the speed of sound is 344 meter per second. If the medium is water, then the speed of sound is 1500 meter per second, almost 5 times. And if it is iron, that is a solid media, then it is 5130 meter per second. So it's almost 3 times that of in water and 15 times that of in air. So from this we understand that the speed travels much faster in solids and much slower in air, in gases. So it's much faster in solids and much slower in gases. So this is the conclusion we get from this. What it means basically when we say in the medium of air, the speed of sound is 344 meters per second. The sound travels a distance of 344 meter in 1 second. In iron, it is 5130 meter per second, means the sound travels 5130 meters in 1 second. That's what the meaning of this. Now let's see what is the other parameter on which the speed of sound depends on. It is temperature. What happens when the temperature is high and when temperature is low? Let us take temperature of air. That is, we are taking it in the medium of air. So if air is at 0 degree centigrade, then the speed of sound is 332 meter per second. If air is at 20 degrees centigrade, that is closer to the room temperature, then it is 344 meter per second. So what it means, when temperature increases, the speed of sound also increases. It means that on a hot day, temperature is higher, so the speed is faster. So the speed of sound in air on a hot day is always greater than on a cold day. From this we conclude, speed on a hot day is greater than that on a cold day. What is the other parameter? The third parameter on which it depends is humidity of air, the moisture content in air. How does it depend on humidity? Let us see. We have two things. One is dry air and humid air. Humid air is where the moisture content is higher. So in dry air, the speed of sound is low. So speed of sound is low in dry air and high in humid air. because of which we can say that the sound travels slower in dry air and sound travels faster in humid air. So it means that as humidity increases, the speed also increases. As humidity increases, the speed also increases. We also have seen from this medium, the sound travels much faster in solids compared to that in water or air. So for this, we can take one example of railway track. See, take a railway track wherein a train is coming. From a farther distance, we can't hear the train approaching us. But you go near to the railway line, which is made of stainless steel, and then put your ear to it, you can hear the sound of the train. So that shows that the sound travel, though the train is very far away, the sound of the train travels faster in the solid, which is stainless steel metal here, than in the air. So we say that the sound travels faster in solids than in liquids or air. So an example for that is the railway track. We need to mention here with regard to sound is, the speed of the sound is supersonic speed. So what do we mean by supersonic speed? We say the speed of an object is greater than the speed of sound. Then we say that that object is going at supersonic speed. Basically, supersonic speed means much greater than speed of sound. From this comes sonic boom. So what is a sonic boom? It is an explosive noise. Sonic boom is nothing but an explosive noise. How is it caused? It's caused by the supersonic speed, which creates a shock waves in the air. A high energy is transferred, so which gives rise to the high variations in the air pressure, and that produces a loud burst. That loud burst is nothing but sonic boom. This we observe in the jet aircraft, supersonic jet aircrafts. And the first supersonic jet aircraft came out in 1948. So what basically this sonic boom? It is nothing but an explosive noise. So let us define the sonic boom. So sonic boom is an explosive noise caused by the shock waves from an aircraft which is traveling faster than the speed of sound. So any object which is traveling faster than the speed of the object, we call it as supersonic speed. And a noise which is caused by the shock waves from an aircraft is called sonic boom.